Hi. So in our introductory lesson on the binomial distribution, we established that a binomial experiment, in other words, the subject of a scenario that you might meet in an exam question, that would be modelled by a binomial distribution if the four conditions are met. All of them have to be met. And these are very important criteria that you will need to memorize going into the exam, because more likely than not, you will have to justify why a certain scenario can be modelled as a binomial distribution. So, just to emphasize, number one, there has to be a fixed amount of trials. In other words, you are doing an experiment repeatedly. It could be tossing a coin, it could be throwing a dice, it could be testing to see if a battery has a certain life expectancy. Whatever it might be, you are doing it again and again and again. And from the outset, there must be a fixed amount of trials. You must be told in the exam question that I'm tossing a coin 80 times, that I'm testing 100 batteries, that I'm looking at the ripeness of 50 avocados. I'm using these examples because these are common examples you meet in the exam. You need to have a fixed amount of trials. Number two outcomes. Each trial must have a black and white type of outcome system. In other words, you are looking for two things. You're looking for a certain property or characteristic, or you're not looking for that certain property or characteristic. Again, I want to cycle through some common examples that you will meet in a lot of the exam questions. For example, when you're tossing a coin, there are two outcomes, naturally, head and tail, or head and not getting a head. If you're throwing a dice, right, you can say, oh, there's 6 outcomes. How can that be a binomial distribution? Well, it can. Who says you need to view the 6 outcomes as 6 outcomes? You could view it as getting a 6 or not getting a 6, getting an even number or not getting an even number, bigger than 3, less than or equal to 3. So even though something might naturally have 6 outcomes, you're looking for, does it have this or does it not have this? Okay, 2 outcomes. And again, the wordiness of the question will be phrased in such a way that you're looking for something very specific within whatever the trial is. Number 3, independent trials. Each trial, whatever it might be, tossing a coin, checking an avocado, looking at batteries, whatever it might be, each trial, whatever that is, has to be completely independent from the next one, which means that every time I toss a coin, it does not affect any other toss that takes place. And as far as the exam goes, you can assume that trials are independent unless there is something a bit suspect going on where there is great evidence to suggest that if whatever I do on the first go will affect the second go, or what I do on the second go will somehow affect the 10th go. If that happens, it's not independent. The best example I can give for that is sampling without replacement. If you have a bag of beads, okay, some are red, some are blue. So you'll have a probability of however many red balls divided by the total. If the probability of a red ball is 3 out of 5, for example, if you sample without replacement, whatever you take out, you do not put it back in, then the probability of the red is going to go down. It's going to be affected. Okay? You cannot say that the probability that I get a red is going to be the same in every single example. So the trials are not independent. And this independent trials is also linked to this, which I've already touched upon, the fixed probability of a success. So what we mean by success is the property that you are looking for, and that will be defined in the exam question. So for example, if you're looking at red balls and blue balls, how do I know which one is a success? The exam question will say so. Okay? It will say that so-and-so keeps on taking a bead and putting it back from a box, and he's looking to count how many red balls he gets. Therefore, a red must be my success. And the probability of whatever success is, whether it's a red ball, whether it's a battery that works, whether it's whatever it might be, okay, has to remain the same. Okay? It has to be the same probability every trial that I get whatever that success is. Now, if they state the probability of a success, whatever that might be in a question, you can assume it remains constant, unless there's an inherent situation like sampling without replacement, that would prevent the probability of a success from remaining constant. So in terms of the wordy style question where you have to justify a binomial distribution, these are the criteria that you must pull out the bag in the exam. But I want to give you a word of warning. The word of warning is as follows. And that is, if you have an exam question such that asks you to justify whether something can be a binomial distribution, then you have to relate it into the exact context of the exam question. What do I mean by that? Well, we know we need to look for a fixed amount of trials, right? You can't say such and such a situation has a fixed amount of trials. You have to say what they are. You have to say there is a fixed amount of trials in this question, and then you have to state what that is. So for example, if the question says, Bob tosses a coin 80 times, that's your fixed amount of trials. You have to specify what that, where is that in the exam question. You have to show the examiner, I understand I need a fixed amount of trials, but you need to go further. You have to say there are a fixed amount of trials, and then physically state what the fixed amount of trials are. Okay, same for this. You can't just say there are 2 outcomes in the trial, you have to state what they are. This is the easiest one, the last one, because the fixed probability of success, you can just state what that probability is. Okay, it's probably going to tell you what that is in the question. So you can say there is a fixed probability of success, and it is 0.44, okay, or whatever it might be. Okay, like this one here, like I said already, the independent trials aspect, unless there's evidence to suggest they are dependent, you can just state that the tosses of the coin are independent. Okay, or every time I test a battery, it's independent. Now something we saw that is quite important is to set up all the various bits and pieces in the exam question so that you're set up to apply the maths from the binomial distribution to a question. So the first important thing is always establish what the discrete random variable is. What do I mean by that? What the binomial distribution actually is, the capital letter, capital X. So, a binomial distribution question, I think it's a good idea to state what capital X represents. Okay, what does that variable actually represent? In a binomial distribution, it will be, in general, the number of successes achieved. In other words, capital X represents whatever the success is in a given trial. You're doing n trials, right? You're doing it repeatedly. There's a fixed amount of trials, let's say 10 trials. Okay, and however many successes you want, that's represented by capital X. So in an exam question, they could say, okay, if you're just tossing a coin, it's the easiest example to use as an example. Okay, if you're tossing a coin, you might be looking for how many heads you get. Now, if you toss a coin 10 times, okay, obviously you might not get 10 heads. So it might ask, well, what's the probability I get 4 heads? So X represents that number of successes, the number of heads, the number of avocados that are ripe. It might be, okay, whatever a success might be. It's always a good idea to write down what X is. Don't write successes, that's just my generic term, okay, because I can't write every single possible X for every single possible question. In general, it's whatever a success is. So it's the number of heads obtained, the number of times I get a 6 on a dice, okay, things like that. The next thing to do, so let's call that number 1. The next thing to do is to label your binomial distribution. If something takes a binomial distribution, if you've established, say in part A of the question, that you've got a binomial distribution, in math we write like this as follows. We write X, which means the number of successes achieved, whatever that might be, that takes the model of a binomial distribution. Remember, if you're just counting how many heads you get, it might not be a binomial distribution. It's only a binomial distribution because those 4 conditions that we listed hold. Okay? You could be tossing a coin repeatedly, and for some reason the probability of getting a head is changing the whole time. Okay? You're messing around with the coin. Okay? Then obviously it wouldn't be a binomial distribution. But if you're counting the number of successes and all the conditions hold, then we say it takes a binomial distribution. What do we say? We say X tilde, this squiggly line is called tilde. You write B, binomial. And then what you do is you fill in N, which is the number of trials, and you fill in P, which is the probability of your success. Maybe it's a head, maybe it's a tail. It depends what this is in the question. So whenever it says to write down what distribution is referred to in the question, you fill this in. So you say, for example, B. Let's say you've got 30 trials, and in each trial I'm looking for a specific characteristic, and perhaps that's the probability of the third. Remember these numbers, these figures, 30 and a third, whatever they might be, that's given in the exam question. Okay, so that's we've got number 1 and we've got number 2. Okay, and then in the exam question, you have to actually translate into maths what we're looking for. Okay? So if they ask you, what's the probability that I get 4 days in May that it rains? So a situation, this is a binomial situation, where you have days of the month of the year, so you've got a fixed amount of trials. So if you've got May, you've got 31 days in May, and you're testing each day repeatedly to see does it rain, does it not rain. Okay, two outcomes, right? Okay, you just assume that all the different days are independent of one another, and it says what's the probability that it would rain 8 days in May? So what you're looking for is you're looking for the probability that the amount of successes, remember success is not always a good thing, most of us don't consider raining a good thing, but if that's the property, that if that's one of the two outcomes that we're looking for, rain or not rain, okay, we're looking for rain because the exam question has asked me about rain, then I say what's the probability that x equals 8, for example. Okay, always write this down. Okay, always write this down. Okay, and we also established last time the generic formula in order for you to do that. So we said as follows, we said that the probability of x is equal to r. Okay, let's use this formula. The probability that x is equal to r, which means the probability that I have r successes, whatever r is, okay, out of n trials. R is obviously less than n. Okay, so you've got how many trials, and I want r successes from those n trials. Now, don't forget, the amount of trials will be determined in the exam question. And in fact, the amount of successes will also be determined in the exam question. They'll have to ask you, okay? Then what we say is n, choose r. That you could just use your calculator. It's the NCR button. That is the amount of trials, which you should know by now from the exam question. R is how many successes you are looking for. That's probably the actual question it's asking. And if you want R successes, we said you multiply the probability of a success. So whatever a success is, the actual probability of that happening, again, should be told in the exam question, to the power of R, multiplied by 1 minus P. So however many successes you have, the rest of the trials must be not a success. So in other words, the probability of not a success, which is 1 minus P, the power must be the remaining numbers up to n. So for example, if R is 2 and the amount of trials is 10, if you've used 10, you've got 8 left. So we say n minus r. All you do is you take that power away from the total amount of trials and you get this power here. Okay, and that's what we said. That's the formula how to do the probability of x is equal to r. What I'm going to do is I'm going to leave this up here and let's look at this from the point of view from an exam question. So this is a classic sort of example you'd meet in an exam. Avi is testing some light bulbs for their lifetimes. The probability that a light bulb lasts longer than 30 hours is 0.12. Avi takes a sample of 30 light bulbs, find the probability exactly 3 of those light bulbs last longer than 30 hours. Now when you're going through a question like this, let's just highlight the bits and pieces that make this a binomial distribution. Because a probability related question in the exam doesn't have to be a binomial distribution. There are other distributions that we will also learn. So let's have a look. I'm going to underline the key phrases. Remember, the first thing you probably want to look at is, do we have a fixed amount of trials? So let's see here. Where do I have a fixed amount of trials? I need to do something repeatedly. Again, I'd probably establish what we're doing. So we're doing, what we're doing, we're looking for the lifetime of some light bulbs. So we're told that over here, that Avi is taking a sample of 30 light bulbs. Given we're testing light bulbs, and it's telling us we've got 30 light bulbs, okay, we're testing a light bulb, testing a light bulb, testing a light bulb. That sounds like a fixed amount of trials. So the 30 light bulbs, that's your fixed amount of trials. Okay, now the next probably important point is that we have to have 2 outcomes. What are we testing in the light bulbs? So let's have a look. Okay, it says here that the probability that a light bulb lasts longer than 30 hours. You might think when you're testing the lifetime of a light bulb, there could be millions of outcomes. Okay, a lifetime could be 5 hours, 6 hours, 10 hours, 2 days, 4 days. There's numerous outcomes, but it's looking for something very specific. It's like the dice. A dice has 6 outcomes, but you can turn it into 2 outcomes by making it black and white. More than 2, less than 2. It's the same here. Look what it says. Okay, the light bulb lasts longer than 30 hours. So it's simply we're looking at longer than 30 hours or not longer than 30 hours. So therefore, the 30 hours, or longer than 30 hours, okay, that's your two outcomes. Longer than 30 hours, not longer than 30 hours. And the actual probability they give for that, 0.12, that's your fixed probability of a success. Again, the last point that we haven't made mention of yet is the independent trials. We just have to assume that the light bulbs are independent. Okay, so that is the assumption here. If they ask the question, what's the assumption? That the light bulbs are independent. Okay, so now let's answer the question. So let's look at it from the actual calculations point of view. So what I suggested we do is you do these four things. Okay, you write down what x represents. You write down the distribution, which I'll probably ask for anyway. Then write down what you're looking for, and then you actually answer it using this formula. So I'm going to go through these four stages to answer this question. Now the actual question says, find the probability exactly 3 light bulbs last longer than 30 hours. Notice what they're asking for satisfies the same characteristic as our success, which is important. Just be careful though. If they've talked about a success being longer than 30 hours, and then they're asking about less than 30 hours, okay, you need to make sure you marry the two up. Just be careful about that. Okay, so if the probability for longer than 30 hours is 0.12, but then in the question they're asking for less than 30 hours, well, don't use 0.12. Do the opposite. Do 0.88. Just be careful. Okay, what you want the success to be is what the exam question actually asks you to do, not what it says here necessarily. It's what the question's saying. If the question's talking from the point of view about lasting longer than 30 hours, fine. We've actually got the probability longer than 30 hours, but it's not hard to get the opposite because it's just two outcomes. If it's longer than 30 hours that I want, great. But if it's not, okay, so I'll just do 1 minus that. It's not really so complicated. Now, so what I said here, I'm going to fill this in. So this was general, and I'm going to rub this out and fill this in. So for this particular example, x represents the number of successes achieved. Okay, so again, what's a success here? It's lasting longer than 30 hours. So here we have x is equal to the number of light bulbs. So effectively, it's basically the number of things, right? It might be people, avocados, batteries, whatever it might be. Okay, the number of coin tosses, whatever it is. It's the number of things that have that success. So it's the number of light bulbs, in this case, that last longer than 30 hours. That's your capital X. Okay, now let's fill this in. Right? So having established this as a binomial distribution, how many trials do we have? Remember, you're testing light bulbs, so therefore the number of trials of how many light bulbs you have. It tells you that. Okay, it tells us that there are 30 light bulbs. So therefore this is 30. Okay? And this is the P. Right? That was my example that I gave, just a random example. The P is the probability of a success. Most of the time it's the probability that's stated in the question. But be careful. Check it matches what they're asking. They're asking lasting longer than 30 hours. They've given us the probability of lasting longer than 30 hours. So that's just 0.12. It's the probability of whatever a success might be. It's basically the characteristic that they're asking about in the exam question. Right, number 3. What they're actually asking, right? How many successes do they want in the question? Look here. It says here, find the probability exactly 3 light bulbs. So for this particular question, they're looking for probability x is equal to 3. So far for this exam question, I would write this down. I'd write this down. It just helps you to have some focus for the question. Write x equals, etc., etc. Write this. This actually is required by the mark schemes for the exam. You must write x, tilde, binomial, fill in n and p. And if it's a wordy question, which it probably will be, write what the actual probability they're asking you to do. Now, that's basically what they're asking you to do. Now let's work it out. Let's use the formula. The formula is over here. The formula is over here. Okay, and again, let's apply this formula to make sure we understand what's going on. So NR, right, N choose R, is a button on your calculator. You'll see it's NCR. On the Class Whiz, the white calculator that you've probably got, you press Shift Divide, and it brings up the C. You just have to place the N and the R either side of that. So therefore, in this case here, N is how many trials you have, R is how many successes you want. Well, I have both of those things. I know there are 30 trials. No, I know there, oh yes, I know there are 30 trials, it's 30 light bulbs, so that's 30 C, and I'm looking for 3 successes. I'm only looking to have 3 light bulbs that satisfy that criteria, which is having lasting longer than 30 hours. So that's 30 C3, or 30 choose 3, like that, but on the calculator you type that, multiplied by P, that's the probability of my success, which is 0.12, to the power of how many successes I want. It's the same as that, 3. But if there are 3 successes, you're doing 30 trials. You're doing n trials whether you like it or not. So if you've got 3 successful trials, i.e. 3 trials with the light bulbs lasting longer than 30 hours, then the rest of the trials must be a fail, i.e. not lasting longer than 30 hours. So it's the opposite probability, i.e. 1 minus 0.88, to the power of the rest of the trials. I've used 3, there are 30 trials, what's left? 27. That's where that n minus r comes from. N is the total trials, that's 30, minus however many you've used up so far. Then just type that into your calculator, which is 0.2224 to 4 decimal places.